Hi, everybody, and thank you for being here with us today. So, today we're going to talk about the architecture, metamorphosis, and how we managed to do so in the biggest financial banking application in Italy, okay? So, just a brief summary on what we're going to see today. Just a small intro on who we are, then we're going to jump to introduction of the slides, and then we're going to see how it is right now and how it's going to be in the future, this application. Few words about the modularization, and then we're going to jump straight into the conclusions. Okay, so who we are. We are from IrisCube Reply, which is a reply group firm. We are focused on finance industry consultancy, which means that we are developing native mobile applications, as well as front-end, web applications, microservices, and many, many other things, all regarding the finance industry. So, few numbers about us, very quickly. We have a profit growth on yearly basis of about 40%. We are a group of 250 developers, consultants, and the average age is pretty low. We are below 26 years old. So pretty young, motivated, talented, hopefully. So, some of our main customers who are here with us today, we have Intel San Paolo, Nexi, and many, many others, all in the finance industry. Enough for all the celebration here. Who's on the stage with me today? We have Marco Balanzino. He is one of our team leaders. He's working on a branch of the mobile banking application in Italy, here in Turin. Then there's our architect, Marco Zanino. And he is the criminal mastermind behind all of this metamorphosis we are talking about today. And, name something, he knows about it. And, there's me. I'm working as a project manager. Excel, spreadsheets, PowerPoints, all those boring stuff. So, let's jump right in. A few years ago, let's think about a real case scenario here, right? Maybe it happened to all of you. A few years ago, in a galaxy not so far, far away, a customer came to us and asked for his new mobile banking application. He invested tons of money for his new mobile application, and, well, at the time, he was quite happy. With the money he spent, well, he managed to get the most he could get. Top-notch technologies, cool UIs, everything brand new, super, super cool. But, things change. Time passes, and today, something changed. Someone told our customer the truth, which is, time's passed, which means things evolved during the first release of the application. And his application right now, it might look old-fashioned. Let's say we developed it before the material design was released. Could happen. And it might have legacy technology. We didn't have architectural components, Jetpack, coroutines, and many, many other stuff that we are using currently today in our projects. And for that reason, it might be hard to find developers knowing those kind of technologies. And for this, developing and maintaining the application is highly expensive, and nobody wants that. All right? So how do you think our customer feels right now? Well, I'll let you imagine who's the red shirt one here and who's the blue one. Okay? So, keeping those things in mind, let's state what are the main points that every customer usually wants in our applications. Even not financial applications, every application, okay? Frequent updates. Who's going to release an application and just leave it there without any new update, new feature, anything? Nobody. You're losing customers. You don't have customer retentions. Everybody wants updates in their applications. They want to stay up to date with the latest technologies, okay? Nobody likes that his application is a legacy one, okay? Of course, high performances. This means that, it has to perform well. I don't think that none of you likes the laggy application that we might see sometimes. Of course, for what we said earlier, maintenance should be easy, especially in financial application as we are developing, all right? You're transferring money. Things are risky, okay? Customers get angry pretty soon. You have to be super careful and must be easy to maintain those applications. And obviously, if you spent tons of money, millions of euros for your application, you don't want to spend it all over again in, let's say, 4 years, 5 years, okay? So lifespan should be longer. Well, all these points are pretty nice, yeah, but those requirements greatly affects how we should think and how we should develop our applications, okay? When we sit at the table and we think about a new application, a new architecture that we are going to implement, we must think carefully about these points, because in the future, if you want to, well, keep our customers, we have to think about this. Okay, so today we're going to talk about what we did in the biggest financial banking application in Italy, and how we managed to survive and stay above the wave in this fast-changing environment. And well, that's not how Bear Grylls would say it. We are not improvising, we are not adapting. The only way to do so is to think and to work hard. So for this, let Marco have the word. Thank you.
Thank you, Alessandro. So now I'm showing to you how initially we implemented our application based on the technologies available at that time. So who know the MVP architectural pattern, the EventBus? Please raise your hand. Okay, perfect, thank you. So I'll try to be quickly so we can go in deeper in the to be and the modularization section. So at the beginning, we decided to use the MVP architectural pattern because we thought that it was the best one available at that time for our purposes. So the ModelView Presenter is an architectural pattern based or derived from the ModelView controller which mostly used for building user interfaces. So as you can see in the picture below, we have 3 main blocks. So the model block, the view block, and the presenter block. The model block can communicate only with the presenter block. The view block also communicate only with the presenter block. So view and model cannot communicate with each other. And so this is the little difference, this is a small difference with the MVC where model and view can communicate. So we can see in detail the components about this pattern. So we have the model that it's an interface responsible for managing data. So in addition, is responsible for using APIs, caching data, and manage some databases. We can see the model like a provider of the data that we want to display in our views. The view is only responsible for presenting data. So we can implement the view by using activities, fragments, and other Android components that can do some operation like updating text view, showing progress bar, and so on. So the last block is the presenter. The presenter is the business logic container. So it's the middleman, the glue between the view and the model, and is responsible for retrieving, for querying the data from the model and updating the view, and also is responsible for reacts to user interactions and then updating the model. So in addition to simplify the Android components communication, we decided to use the EventBus Java library. So the EventBus is based on the publish-subscribe pattern. It's a simple Java library that can be represented by this picture, where we have a publisher that posts an event on the bus, and then the bus propagates the event to the subscriber. Here we have a small example about this pattern. So as you can see, we have a publisher, the repository, that retrieves some data and then posts the data, the full response or the exception, to the bus. And then we have the subscriber, the full presenter, that subscribe this type of event, so the full response or the exception event, and then when the bus posts the event, the subscriber wake up and manage the response. But which kind of issues we have in this type of pattern. So let's imagine to have two presenter, the full presenter and another presenter that subscribe the same event. So who received the event? We don't know. And also, let's imagine to have two repository. So the full repository and another repository that posts the same event. We don't know who posts the data. We don't know the data source. So based on this aspect and based on our experience, we can say that with this library, we have some advantages and some negative aspects. So the pros aspects are that you can decouple the senders and the event receiver events. So you can simplify the listener-based architecture. And also, you can change the event thread by avoiding UI blocks. UI blocks, yes, sorry. And then it's easy to pass small objects to the event. But the negative aspects are that is if you have a large use of this library in your application, you make your code more unreadable and more untestable. So also, each subscriber needs their own event method implementation. So this makes your code more understandable, especially for the newest developer. And finally, yet importantly, you lose the control over who notifying whom. Okay, so we can summarize all these points in one sentence. So the EventBus doesn't let you know the source of the data, and the class reuse is highly dangerous. And based on this sentence, based on our experience with this library, and based also with the need to reuse some existing class in our project for developing new feature, okay, we decide to put aside the EventBus library and to migrate to RX Java. RX Java is a Java reactive programming library, and so the reactive programming is based on the event propagation. And then we can identify two main subjects in this type of pattern, the observer and the observable. The observable are the emitter of the data, so emits the event. And for example, post a result by from a network call. And the subscriber, the observer, consume the event emitted by the observable. And here we can see a small example, or better, the same example with observer and observable. Sorry, the observable and the observer. So the observable posts the result, emit the result about, for example, a network call, and then the observer catch the response, and then manage this response. The difference is that the code is more readable, more concise, but the main aspect is that you know who posts the result and you know who receives the result. Because we observe a specific instance about the single, and then we can manage the specific response, the full response or the exception response. So I have a question. How can we improve our application? So I think that's not all.
Okay, well, Marco, I would probably say that a good approach would be start using Android architectural components, since ViewModel and live data are good tools for us because of reduction of many boilerplate codes that we were using throughout the presenters, our repositories, and and maybe I would also suggest to move to Kotlin, for example, and why not coroutines? But it isn't an easy task. We have to decide what approach to use. And we could think of many approaches to move from an MVP to an MVVM architecture. Well, the first one would probably be the simplest one, that is taking all the code from the presenter and put it inside of your model. But, well, I don't think that would be great for us, since presenter could manage many models inside of it. Instead, a view model has to manage only a specific model. And, well, I wouldn't suggest to use that. Well, the second approach would be taking all the business logic that we had in our presenters and move it to the view, delegating that code to the view. And so having many view models for each model that the presenter were using. But maybe we want just to reuse a single view in another part of our project. And, well, because of the tying up of the business logic, we wouldn't be able to do that. And so we have to introduce a component to hold all this business logic. And this is so-called use case. We can think of it as a function, a simple function, but we will see later how to use it. And so, in this pattern, in the MVVM pattern, the view will have to be just like in the MVP pattern. So just display themselves and dispatch or transform user interaction into model interaction, interaction. And then the view model will only have to expose some APIs to access the model and handle it. And I think that is the one that wins. And so let's summarize what are the components in our pattern. So we have, as we said, the model, that is just the data layer, and it is represented by the view, for example. Then we have the view that displays some information, some useful information to the user. And, well, it just do another thing, that is observing the view model, because he wants to know when the model will be updated, sooner or later. And then we have the view model that actually retrieves data, retrieves the model, and manages it. But it also has to make, in some way, the view able to be updated of model of changes over the model. And, well, I would probably use live data, since live data is a part of the Android architecture components, and it is, well, an application of the observable pattern. And it is very useful because it is lifecycle aware. So when the view, in our case, so it could be a fragment or an activity, is going to be destroyed, live data knows it, will be notified about that, and so it will automatically unsubscribe the view for us. And that greatly avoids memory leak. And here we have our use case. That is a great boilerplate code reduction, as we will see in the example later. And it is, well, a wrapping of some business logic that we want to maybe reuse inside our projects, in different parts of our projects. And so let's have a small example. Here we can see an activity, that is the view, for example, that wants to retrieve some a list of something from the view model. And the call above, that one, is how the view is actually subscribing it to receive updates over the model. And then we have the view model, of course, that is actually doing nothing. It's just delegating all to our use case. And it becomes pretty simple. That's why of the boilerplate reduction that we mentioned earlier. And then we have our use case. Our use case simply, in this case, wants to retrieve something from a repository. And, well, that's it. And we just call it as a function. That is a great thing, I think. And here we see that here it's pretty simple, but all the logic of switching to a neutralized, retrieving the data and posting it back to a live data is done by the use case, the base class. And that's pretty awesome. But here we have to handle all the context of our coroutines, since we are using it. And let's have a quick look at what coroutines are, but maybe you will know about it. And we have thought that replacing RxJava with coroutines was a great thing for all our developers because, well, RxJava is not simple to learn, I think. And with coroutines, you will have a more concise code, and you will handle all the asynchronous tasks in a sequential-ish manner. And they are very lightweight. And we can see an example of those coroutines applied. So just to switch to a new thread to do something, you could use launch. And in this block of code, you can do whatever you want without having to be concerned about the UI thread. And maybe you want to return some value in an asynchronous manner, and that's it. You have just to call async, and we will have all the work done. But, well, in our case, the project was born 2 or 3 years ago, and then we had choose to use a single monolithic module because Gradle wasn't so performant to handling many modules. And so the next step will be modularize our current application. With modularization, you will have great benefits, but it is not an easy task. Well, in theory, it would be easy because we will only have to create a core module that will handle all just the code that, for example, network calls, code to make network calls. And this module will be shared between many feature modules, hopefully independent functional modules. And all those functional modules will use those core those core module to make all the boring stuff, well. And then we need something to connect all those independent modules, and that is the app module that will have to handle all the navigation between those functional modules. Well, in theory, it's pretty simple, but how can we manage this in practice? So maybe one approach would be start smashing all what we have, our code base, into single pieces, like a monkey would do that? Maybe that isn't so great. We have to carefully think how to manage this. Here in the picture, we can see how we managed to do that in one of our projects, and that is, well, you have a long list of modules, indeed, and well, but we can actually see that we have put aside our network layer. Here, maybe you can't see it there, but it will be also present a security layer for our case. And then we have many functional modules. For example, well, the login modules. But we decided to split, to make a fine-grained splitting of a functional module in 2 separate pieces. So the module that will wrap all the domain layer, the data layer, and another module that will contain only the UI components. That's because maybe we want to reuse the same login logic, but in another project. And that's it. You will only have to publish in some way, maybe with a library, or just copy and paste the login module, our domain layer, and that's it. You will only have to create a new UI, for example. And so, we have listed some pros, but there is also some negative aspects, or, well, not negative, but some aspects that you take care of. So, for example, it is very easy to mess up with dependencies. Maybe you have a module that uses support 23, the support version 23, and another that uses support 28. And that would be not good because you will have some issue during the build process. And we managed to fix actually this issue with using in the build source file, defining a class that is just an holder of all your dependencies, and that's it. You will have it inherited throughout your project. And well, if you start using from a functional module, another functional module, and another, sooner or later you will end up with a dependency cycle for sure. And that is why we mentioned that functional modules will have to be independent. But, well, not a problem. So, but there are also other pros. That is, the code will be more testable because will be finally separated into certain modules, certain blocks. And, well, if you have many developer teams, maybe you have a developer team here in Turin and another in Milan that are working, all of them that are working on the same project, but in different functionalities. And that's it. You could have it because you will, with separating in using modules, you will we don't have to handle merge issues maybe. And it is pretty simple to publish a module. As we said, if you want to use some module in another project, you will just have to create a library, and that's it. You can reuse it all the times you want. And, well, maybe your customer wants to have a look at some functionality of your project. You could create a demo app. Why not? Just by not including the functional modules that the customer don't want to see. But, well, I think that one of the most important pros is the speed of the build time. With a monolithic module, our build time was 10 to 20 minutes, yeah, or so. But using a multi-module, the build time has decreased of, well, many times. And, well, the good old times when we started a build just to relax. But that will be no more with our improvements, with these improvements in mind. And so, just to conclude.
Okay. Jumping straight to conclusions. What we learned today, okay, in this topic. Well, first of all, thank you for your attention. And, well, first point that we learned and we take home with us is that MVVM can successfully be used in large financial application as we do currently in our projects, but that can be, in any projects that we might think of. The second point is the most shocking one that when I first heard about it, I was saying, okay, no, we cannot do this at all. In fact, we managed to do so. So we managed to successfully migrate from a pattern to one another. It was not an easy task, all right? It was not a 2 days work, but it's not impossible. So next time your customer asks you something like this, be aware that somebody did so, and don't worry, it can be done, all right? Third point, obviously, since based on what we know now, all our future applications will be based on this pattern and all the components that Marco said, all right? And I heard in other talks that many other speakers talked about the modularization. We didn't know about that, but it's a pretty fine thing, all right? We dropped the time build from 20 to 3 minutes, all right? This is a huge save of time and money, okay? And based on this, If you remember the first 5 points we talked about in the introduction, you know, the 5 things that our customer wants when we build an application for them. Well, I think that this way we managed to fulfill all their dreams. We are saving money, they are saving money, they are not having a legacy application, and well, if everybody is saving money, I think that everybody's happy, okay? So, thank you for your attention. We couldn't dive in the code, in the technical details too much because of the time we have. So if you have any question, please feel free to ask to us right now. Otherwise, you can find us in the golden sponsor area right at the center, and we'll be happy to answer all your questions. Thank you.